Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Qaidi Adik bin Zaidi. I'm from Group 6. Today, I'm going to present about the general road accidents statistic in Malaysia. Firstly, this dataset shows the number of road deaths in Malaysia as the independent variable X and the road safety index per 100,000 population as the dependent variable Y. In general, higher numbers of road deaths tends to be associated with changes in the safety index, but the relationship is not always linear because it can be influenced by factors such as population growth, enforcement level, infrastructure, and driver behavior. There are three objectives to be achieved in this study. Firstly, to determine which model provides the best fit using the sum of square of errors. Second, to construct and compare least square linear and quadratic functions based on the given dataset. And lastly, to interpret the results and understand the trend of road safety in Malaysia based on numerical analysis.
This slide shows the data used in this study, which focus on the relationship between road death and index per 100,000 population in Malaysia. All data presented in this study were obtained from the Malaysian Institute of Road Safety Research, MIROS. Next, this slide shows the construction of the least squares linear function based on the given data. The least squares method is applied to minimize the sum of the square errors and to obtain the best fitting linear model that describes the relationship between the number of road deaths and the road safety index per 100,000 population in Malaysia. Based on the calculations, the linear function obtained is fs equal to 37.626 minus 0.00213x. This equation represents the estimated linear relationship between the two variables, where the value of the road safety index is modeled as a function of the number of road deaths. Let's take a look at the graph. From the graph, this function is plotted together with the observed data points to illustrate the overall trend. The graph shows a negative linear relationship indicating that as the number of road deaths increase, the road safety index tends to decrease.
Like I will explain how the quadratic least square approximation is obtained. First, we choose a polynomial degree of m equals to 2, so the approximating function is fx equal to a0 plus a1x plus a2x squared. Next, we construct a normal equations which are shown at the top of the slide. By solving this system of equations, we obtain the coefficients a0 equal to 27.1578, a1 equals to 0.011549, a2 equals to negative 2.5648 times 10 to the power of negative 7. Finally, substituting these values into the original equation gives the quadratic approximation fx equal to 27.1578 plus 0.011549x minus 2.5648 times 10 to the power of negative 7x squared. This function represents the best fit curve for the given data using the least square methods. Graph shows the quadratic regression result for the given dataset. The blue dots represent the actual data points collected from the observations. From the graph, we can observe there is a slight downward curvature which indicates a weak negative quadratic trend in the data. As the x value increases, the y value generally decrease, although the data points are somewhat scattered. This means that while the quadratic model captures the overall trend of the data, there is still some variability that is not perfectly explained by the model. Overall, the curve represents the best fit approximation of the data using the least squares method. This table summarizes the data value, model predictions, and error analysis used in this study. By comparing these two error columns, we can see that the quadratic model generally produces small errors than the linear model for most observations. This indicates that the quadratic model provides a better fit to the data compared to a linear model. Overall, this table demonstrates how the quadratic least squares approximation improves accuracy by reducing the total sum of squared errors. The linear and quadratic regression models were used to fit the data, and their accuracy was evaluated using the sum of squares of error. For the linear regression model, from the equation obtained with an SSE value of approximately 41.564, this indicates that the total squared difference between the observed values and the values predicted by the linear model is relatively small. For the quadratic regression model, the SSE value is approximately 41.5296. Since the quadratic model has slightly lower SSE, it fits the data marginally better than the linear model. However, the difference in SSE values is very small, suggesting that both models perform almost equally well and that the relationship between the variables is close to linear.
Based on the SSE values, the quadratic function provides the best fit to the data as its SSE is slightly smaller than that of the linear model. This indicates that the quadratic model fits the data marginally better, although the difference is small, meaning both models have a similar level of fit. The quadratic model includes one additional parameter, the x-squared term, which results in a slight reduction in SSE. For the conclusion, this project successfully used numerical methods to analyze the relationship between road death and the road safety index in Malaysia. Both linear and quadratic least squares models were constructed and compared using the SSE values. The quadratic model gave a smaller SSE, showing that it fits the data better than the linear model. Overall, the project shows the mathematical modeling is useful for understanding real data and can help support better analysis and decision making in the future.